Hello, welcome to the next video in this 8400 lecture series. Today we're going to be discussing quality concepts. So this will be the first lecture and discussion around the idea of software quality. Before I get started, I'd like to make a note here that for this particular course, we won't be diving into the particulars and details of software testing, but more getting a general overview of the importance of software quality and some of the assurances that can be taken to ensure that it is quality software. The details on testing and the diving deeper into that will be done in a future course. All right. So, first off, what is quality? These are the three types of software quality. We have quality of design, which refers to the effectiveness and adequacy of a software design's process. It's considering and understanding requirements of the software, creating detailed specifications, developing a well thought out design of the system. This is going to be various aspects are involved, including functionality, performance, usability, reliability, maintainability. And the design phase ensures that the software meets the intended purpose and includes all the necessary features and capabilities. So just so you understand, we dive deeper also into design in the next course, but it's good to get an idea here that not only does the code need to be of quality, but the design itself has to have quality to it in order to ensure that the product or the software is going to be high quality itself. So on the other hand, quality of conformance primarily focuses on the implementation phase of the software development process. It's concerned with how well the design is translated into an actual working system or software. So that includes verifying that the implementation adheres to specific requirements and design specifications without deviation, ensures the software accurately reflects the intended design, and effectively addresses any sort of functionalities and performance targets. Finally, our user satisfaction is the ultimate measure of success for any software because we want to make sure that the user is satisfied. It's a holistic evaluation of how well the software meets the needs and expectations of its users. So the equation, user satisfaction equals compliant product plus good quality plus delivery within budget and schedule, really highlights the factors that contribute to user satisfaction. So compliant product, good quality, delivery within budget. What else could you ask for? Oh, delivery within schedule and budget. Yes. Okay. So there's a couple of views around quality. Some of these go into some more philosophical ideologies, but I'll walk through these with you. We have our transcendental view, which argues that quality is something that you immediately recognize, but you can't really define. A user view sees product quality in terms of meeting the end user's specific goals. So a lot of different software engineering philosophy is met around that, especially agile processes. The manufacturer's view is that quality is in terms of making sure that the product meets whatever specification started with. The product view suggests quality be tied to an inherent characteristics, such as it has certain features or functions. Our value-based view is going to measure quality based on how much the customer is willing to pay for the product. So that's all about the money. Quality really encompasses all of these and more. So there's no one answer to what quality is or the proper philosophical definition of it. So here's a formal definition: an effective software process applied in a manner that creates a useful product that provides measurable value for those who produce it and who use it. So an effective software process applied in a manner that creates a useful product that provides measurable value for those who produce it and those who use it, which I think pretty much covers everything. What are the advantages of creating useful products? Well, they're useful. Other than that, We also get more money from them. That's our product revenue, better profitability when it supports a business process. And we also get a lot more information that's crucial for the business when the product is working correctly. All right. So an effective software process establishes infrastructure that supports building a high-quality software product. What this basically means is that our processes need to be established. They need to be something that everybody who's using them has been trained in or knows how to use them, and they're confident in their use. That is going to lead us to a high-quality software product. If we have project chaos, it leads to poor quality. Think about when you've been on a team with someone and they didn't know what they were doing, or they didn't know what the process is, right? So that creates lots of chaos and you end up with poor quality. If you have management checks and balances in place, you can avoid this. So to mitigate the impact of project chaos, you definitely want to have these checks and balances in place. This brings structure and control to the project. Some of the measures may include establishing clear project objectives, defining roles and responsibilities, implementing project management methodologies, enforcing documentation and change control. So change control is all about ensuring that whatever process is in place when changes need to be made, that it is followed. That allows us to have better expectations around what we should see with the changes. It reduces the amount of uncertainty and creates less chaos. And speaking of changes, change management, technical reviews, very important to software quality. Sorry, apologize for clearing my throat. Change management is going to help evaluate the impact of requested change on the software design, requirements, and overall quality. Our technical reviews, such as code reviews, design reviews, are going to give us evaluations of the software artifacts that allow us to identify defects, adhere to coding standards, and align with our architectural and design principles. This gives us a chance to catch our errors, optimize performance, and improve the overall quality. All right, so a useful product is a product that is going to deliver the content, functionality, features that the end user wants in a way that's reliable and doesn't have any errors. I don't know about you, but if I download an app on my phone or if I'm using an app on the computer, I want it to be reliable and error-free and give me what I need. And if it gives me extra stuff, great. As long as there's not so much stuff, I get lost and confused. Let's take Microsoft for an example. I like Microsoft OneNote. I use Microsoft OneNote on the regular. I like the way it organizes things. I like the way it does most things. It's reliable, in that it works every time that I use it. It works the correct way. I won't say it's error-free. I found that using OneNote on 365, if I download it into a .1 file and try to put it onto another cloud or view it on anything other than a Windows machine, it is not reliable because it won't open. So that's an issue. Another thing I found really obnoxious about OneNote is that it does not allow me to default set the size of my font when I open up a new note, so I have to constantly change it. Obnoxious. These are features I would love to see in OneNote, but on the majority of the time, it's reliable and it usually is error-free, and I really appreciate the way it organizes things. It's a useful product for me. Same for all the Office products. Are they perfect? No, but they are useful. They satisfy me as a stakeholder, my requirements, and it satisfies the requirements that are expected of high-quality software. Yeah, I mean, I'll say they're high-quality software. I've had times where I've used other apps or software where it's definitely not been high quality. They're crashing or they can't handle certain things. Microsoft does a pretty good job of not having that happen. Could they be better? Sure. high quality software for the team, software team, less maintenance, fewer bug fixes. It's kind of the same thing. Although maintenance, you'll learn eventually, is more than just bug fixes. Reduced customer support. So we don't have to have our ChatGPT AI do as much answering of phone calls. And then the user community gains and expedited business processes. So the idea here is that we want the users to be gaining some sort of value, right, in their business processes. So that's what quality software is going to bring to them. By adding value for both the producer and for the user, we're going to get benefits for everyone. That's the idea. All right, so McCall's came up with some cool quality factors that I'm going to walk through. First off, they're divided into three categories: product operation, product revision, and product transition. So in product operation, we have correctness, meaning the software must meet their specified requirements and functions without errors or faults. Reliability, the software utilizes system resources effectively and efficiently to achieve its intended tasks in a reliable manner. Usability means that it's user-friendly, intuitive, easy to learn. Users can interact with it in a way that's efficient and reliable. So integrity, that's going to protect the data and system integrity by preventing unauthorized access, data loss, or corruption. And efficiency is going to utilize system resources effectively and make sure they're done in a timely manner. So for our product revision, which is over here, we have flexibility is the ability for the software to adapt and accommodate to new requirements. Testability, the software can be tested, ensure that it's quality, identify defects and errors. And they have testability on here twice. That's pretty funny. Okay, well, I already said testability. Maybe it's just that important. Finally, for project transition, we have portability, which means the software can be transferred or ported to new platforms in a way that is so that can be reused in other applications. That's also reusability, and we don't have to have significant modifications around these. And interoperability means it can interact and okay, sorry about that. So interoperability means the software can seamlessly interact and operate with other systems and components, enabling smooth data exchange and integration. All right, so all these complicated things up here, these characters, are ISO 25010-2017. So it is a standard around software quality. And this is basically the different things that are listed under that standard for quality and use. We want effectiveness, efficiency, satisfaction, freedom from risk, and context coverage. So you can read those if you'd like. Product quality under that same standard. We want functional suitability, right? Performance efficiency, compatibility, usability, reliability, security, maintainability, and portability. A lot of abilities. You can see there's lots of different aspects to having software quality. So if you want to meet this standard, all of these different aspects need to be of a certain quality caliber. I just thought I'd throw that in there to show you that there are actual standards out there that companies work towards maintaining their software at. So a lot of you know what the difference between qualitative and quantitative is. Qualitative is going to be gathering data that is not going to be as numeric, not as measurable in a granular way, as quantitative is going to be more numeric and can actually produce statistical results. So qualitative and quality assessment means we focus on the complete software product. We're going to give user questionnaires and then a set of structured tasks for the user to be interacting with. We may be watching them while they're actually doing the task or questionnaire, and then this is very important to test in production. So, it's going to be an assessment of observation, more qualitative, not really like saying, okay, they enjoy it 6 out of 10%. It's more like, okay, they complete this task, they're capable of doing it, they seem to enjoy it. Quantitative, on the other hand, is giving us precise measures for our software quality. We have lots of measurements, KPIs, internal code attributes. There may be red flags in place, which we have acceptable ranges, and if it goes out of those range, then it is a red flag. The one thing to remember or know is that we're not really measuring quality itself. We're measuring a manifestation of quality, right? So flexibility, testability, reusability, all of these different manifestations of quality. And then the relationship between the variable that is measured and the quality of software is going to complicate things because correlation does not equal causation in all situations. And so you may have a correlation between a particular variable being measured, and you may say, okay, that's correlated to the software quality, but that's not always true. There has to be a lot of critical thinking around it and an examination of the situation before that can be stated infallibly. Infallibly. That's the right word. Okay. All right. Software quality dilemma. So you're going to get terrible quality. If you get terrible quality for your software, no one's going to want to buy it. Okay, that's a no-brainer. If you spend infinite time and extremely large effort and large sums of money in your software, it's going to take you so long to complete and be so expensive that you'll be out of business. So that really doesn't help. In industry, you want to find that magical middle ground where the software product is good enough not to be rejected right away, but also not the object of much perfectionism, as it would take too long to complete. And we have Leslie Knope to let us know what that looks like. Okay, so there's arguments out there about whether software should be good enough. I think in your book, The Pragmatic Programmer, it talks about the concept of good enough software. Your book goes into some arguments around against good enough software. So it's true in some situations, good enough software is fine, right? Like maybe you have like a major software company like Amazon, and they can put out a piece of software that's okay, and they're not going to like crumble under the mediocre reviews. That being said, if you work for a small company and you deliver a good enough product, you may be damaging your company's reputation, and it may be something that makes your company go under. There's also certain application domains, such as real-time embedded software, the type of software that is handling 911 calls, where good enough is negligent and is actually going to lead towards you having some sort of litigation, right? You'll be reading a little bit about this when you get into the software legality at the end of this course, but it's very important to understand that these companies and people, and especially these mission-critical applications, rely on the software in a way that is going to really put your company in a position where they could be facing expensive litigation for poor quality software. Okay. So let's talk about the cost of quality. So prevention costs, these costs are incurred to prevent defects and issues from occurring in the software development process. Prevention costs are invested upfront, and they ensure quality is built into the software right from the beginning. So technical reviews, planning, training, test equipment. Appraisal costs are going to be associated with evaluating and assessing the quality of the software during and after its development. So these are incurred to ensure that the software meets specific requirements and quality standards. So this could be conducting technical reviews, collection of data, metrics, quantitative data, testing and debugging is a huge one as well. Our internal failure costs are incurred due to defects or issues that are discovered during the software development process. It could happen before it's delivered to the users, or it could arise afterwards. And so that could be that you have to rework to correct the defects, repair things, do a failure mode analysis. Either way, it's going to cost money. External failure costs are actually going to be incurred when defects and issues are discovered after the software is delivered to the end users. So ignore what I said previously about how it could, internal failure costs could be after. This one is the one that's after. So this failure costs happen after it's been delivered. It can negatively impact customer satisfaction, increase support requirements, and lead to potential revenue losses. And so that's going to require you to have to deal with complaint resolution, product return and replacement, which affects the bottom line, and help line support. So you'll have to get yourself some AI to answer the phones. Okay, that joke's getting old. All right, so this chart right here is just giving you an idea of the further along the line in the stages of development, the more our defects are going to cost to repair. So we want to catch them as early as possible. All right, so let's take a look at an example of how negligence and liability can occur. So we have a corporate entity who hires a major software developer to construct a software-based system. Okay, so you have a corporation that hires a software developer to construct a system. The system supports some function, so it's going to, let's say, administer healthcare information and file it, and maybe it's for a hospital. Work begins with the best of intentions on both sides. Everyone's eager and on board. We're actually having some meetings, communicating, requirements are being set. We're in good shape. Sadly, things go bad. The system is late, fails to deliver desired features and functions. It's error-prone and does not get customer acceptance. Perhaps it violates HIPAA and does not account for patient information. And then litigation ensues. Because, here's the situation. You got this corporation, it hired a software company, and it says, I need this product, right? So I need you to deliver this product to me on this time. And they're relying on them to have it delivered at that time. They're making plans, they have situations, they have infrastructure in place. Their expectations are it's going to be delivered on time or somewhere after, not long after. The company invests a lot of money and time in their developers developing the product. Months pass, things go bad. It ends up producing a product the customer does not like. We go through multiple iterations. Eventually the customer says, forget it. You had a whole year to do this, and you have not given us what we need, and so we do not want to have you produce our product, but we've already wasted all this money on it. Now there's a litigation to handle. So this is really the importance of ensuring quality, because these things destroy software companies or whatever company's producing the software. Something to keep in mind. All right. Low quality software is also going to be easier to hack. If you want a piece of software that's secure, you're going to have to focus on quality for sure. Here's some impact of management decisions. So estimation decisions. If we have irrational delivery date estimates will cause the team to take shortcuts that could lead to reduced product quality. So people are rushing. They think they have to get things done early. I don't know if there's any gamers out there, but if you take a look at Cyberpunk 2077, I feel like their company was pushing them to get it out at a certain delivery date. And so when they produced the product and then people started playing it, they hated it. It was notoriously one of the worst game releases that's ever been, because it was full of bugs and errors because the management had an irrational delivery date. Scheduling decisions, failing to pay attention to task dependencies when creating the project schedule, and risk-oriented decisions, reacting to each crisis rather than proactively preparing for the risks. is going to lead to serious problems. How do we achieve software quality? Well, we want good project management, solid engineering practice. Not only do we need a good project manager, we need a good team of developers and a good team of software engineers. We want to understand what the project is and have a quality design that is going to meet our problem requirements. And here it's just talking about how the project plan needs explicit techniques for quality and change management, using estimation around delivery dates that are achievable, the schedule is understood, no one's taking shortcuts, like the example I just gave, and risk planning is conducted ahead of time, not reactively, but rather proactively. Want to ensure there's quality control, so we have inspections, reviews, tests. We talked about this already. Quality assurance, which is what we're going to talk about in the next video, where we do auditing and reporting procedures to provide management with the data that they need to make proactive decisions, not reactive decisions. Defect prediction is a big deal. A lot of times, there's a lot of movement towards trying to use machine learning statistical models to help identify the relationships between metrics and defective components so that we can actually do a prediction on if there's going to be a defect present. And that'll be a big deal when that's implemented fully. So that is the end of this video. Thank you for joining me, and I'll see you in the next video.